So let's review some concepts. There's only one real new concept in 2.6, and that's your slant asymptote. So it allows you the benefit of really learning the concepts that we've been looking at. So if you're at all unsure about anything we talk about, you've got to ask questions. So you're going to look at rational functions today specifically. And so these are examples of rational functions. And you're going to be asked to find all of these different things at various points in your homework. So if I'm finding the domain, remember restrictions on domain would be a variable in the denominator. So my denominator cannot be 0. So what would be my domain restriction here? X cannot be -3. So if x cannot be -3, then my domain is going to look like this. My domain is going to go from the leftmost x value, which would be -infinity. I come to that restriction of -3. Would you mind shutting that door? And I don't want to include it. I hop over -3, so I want to union that. I have to start the next interval with -3, and then I go to +infinity. So what this does is it cuts the x-axis in one spot, and it cuts the x-axis into 2 pieces. So you should have an interval representing those 2 pieces. What about this one? What are your restrictions here? Yeah, x cannot equal -3, and x cannot equal -1. So this time the x-axis is cut into 2 places. And so when it's got 2 cuts on it, it creates 3 intervals. So our leftmost x value here is -infinity. I come to that restriction of -3, and I don't want it. So it's parentheses. In union, I must start the next interval with that -3. But I'm going from -3 to -1. So I'm going to close parentheses. And then union, I go from -1, so I have to start that interval with -1. And I go to positive. So the more cuts you have, the more complicated your domain might look. So that's nothing new. Correct. If there's no variables in the denominator, then your domain is unrestricted. Right? Then your x-intercept, well, on the x-axis, your y value is 0. So that's why this is saying y value is 0. Well, as you look at fractions, the only way for the y value to be 0 in a fraction is if the numerator has a value of 0. It doesn't matter what the denominator is. For a fraction to be 0, it has to be 0 over something. So that's why we wrote in here that your numerator gets set equal to 0. So it's just like finding restrictions on the denominator. We set that equal to 0. You're going to set your numerator equal to 0 to find any x-intercepts. Is there any way for 1 to equal 0? And this one? Nope. So there's no x-intercepts for this one. So sometimes it's not going to cross the x-axis. But here, if I set that equal to 0, what would x be? -2. Pardon me for yawning. So, didn't have much sleep. So x is equal to -2. Or it's going to cross the x-axis at -2. Your y-intercepts, you're going to let x equal 0 and you're going to evaluate the function when x is 0. So you are going to let x equal 0 and evaluate the function when x equals 0. So you're going to find a y value when x is 0. So for these fractions, 1 over x plus 3, this is really y equals 1 over x plus 3. So if I let x equal 0, that means that my y-intercept is going to be 1/3. Right? So this is going to cross the y-axis at 1/3. If I let x equal 0 here, I have a 2 in the numerator. If I let x equal 0 here, this part becomes 3. Let x equal 0 here, this part becomes 1. 3 times 1 is 3. 2 over 3 is 2/3. So this fraction is going to cross the y-axis at 2/3. So that's how you find your y-intercept. Then your vertical asymptote, is closely associated with your domain restrictions. When you find your domain restrictions, if there are any, then you have found your vertical asymptotes. Vertical asymptotes go through what axis? Vertical goes through the x-axis. So they will always be in the form of x equals some number. So up here, these are written in vertical asymptote form. They're written, except for the not equals. And I don't care if you write the not equals or just the plain equals, it doesn't matter. But the vertical asymptote here is x equals -3. And here, x equals -3 and x equals -1. So when you find those domain restrictions, you've found your vertical asymptotes. If there are no domain restrictions, there are no vertical asymptotes. Then finally, we have our horizontal asymptotes. If you recall, there are 3 different situations that could occur. You are going to compare the degree of the numerator to the degree of the denominator. And there's only 3 possibilities. The degree of your numerator can be less than the degree of the denominator. If that occurs 100% of the time, your horizontal asymptote will be y equals 0. It doesn't matter what the degrees are. If the numerator is less than the denominator, y equals 0 will be that horizontal asymptote. So here's an example here. The degree of this numerator is 2. The degree of this numerator is 3. 2 is less than 3, so y equals 0 is that horizontal asymptote. And if you graph this on your calculator, you'll see it approaching y equals 0. The second situation is if the degree of the numerator is exactly equal to the degree of the denominator. If that happens, you have to look at the ratio of the leading coefficients. So on this one, my degree of the numerator is 2. On this one, the degree of the denominator is 2. Since they equal, we're going to look at the leading terms coefficient. So those are the 2 terms that hold the highest degree. The coefficient of the x squared is 1. So I'm going to take the ratio of 2 over 1. So I get y equals 2 over 1, and that does reduce to y equals 2. So when the numerator and denominator agree, your asymptotes will be different. It's not always the same. Then the last situation is the numerator degree is greater than the denominator degree. If this occurs, there is no horizontal asymptote. So here I've got 3 is greater than 2. There's no asymptote. What could occur, however, you could have a slant asymptote. And the slant asymptote occurs when the degree of the numerator is 1 more than the degree of the denominator. And you can find your slant asymptote by using either long division or synthetic division. So if you look at this particular example down here, the degree of the numerator is 2. The degree of the denominator is 1. You have an exact difference of 1. So there's a slant asymptote, which means that it's going to be a diagonal line. If it's a diagonal line in the coordinate grid, what form do lines, how do we graph lines? What form are they in? Y equals mx plus b, right? So you're going to use synthetic division to find the slant asymptote in the form of y equals mx plus b. But you might want to include in here that when we do synthetic division, we are going to ignore any remainders. If there's a remainder, we're going to ignore it. It's not important. So look at your numerator here. Am I missing any terms? Nope. So use your coefficients, 1, -1, and -2. Putting your vertical lines in your shelf. Then I am dividing by x minus 1. So what goes on the shelf? A positive 1. And we're going to bring down that first term, and we're going to do the multiplication. So 1 times 1 is 1. Add down, I get 0. 1 times 0 is 0. Add down, I get -2. I don't care about the remainder. I'm not looking for a 0, none of that. All I care about when I perform the synthetic division to find that slant asymptote is that part of that final line. Because didn't I start with an x squared? And I'm going to an x? Well, I start with an x squared, that means that this should be an x. So this is y equals mx plus b. So my slant asymptote is what? Y equals just x, because we don't write that plus there. And so this is our slant asymptote. And I'll prove to you that it works. And I'm going to put this in my calculator, and you'll see the slant asymptote. Let's get rid of the glare. And we have parentheses x squared minus x minus 2 divided by parentheses x minus 1. So here you can see the swoops occurring, and that y equals x goes through the y-axis at 0, and it has a slope of 1. So when you are plotting the slant asymptote, you have to actually plot it correctly. You have to plot the y-intercept. You have to stair-step that slope and plot the points and connect them. You can't just sketch it in. You have to graph it accurately. All right. So let's look at some additional problems. Any issues, problems, or concerns with that? We'll work more on the slant asymptote. Or 2 or 3 or 50. All right, so let's look at one of our basic functions. The 12 basic functions that we had before was 1 over x. We're going to look at transformations of rational functions. So let's go ahead and graph this basic function. You should already know what it looks like, but if you don't, we're going to explore what its vertical and horizontal asymptotes look like. So I've got a vertical asymptote. Is there any value that will make the denominator 0? 0. So my vertical asymptote is going to be x equals 0. And so that means that that is the y-axis. So I'm going to label that as x equals 0. If you don't label the axis, I don't know that you know that that's an asymptote. Then let's look at horizontal asymptotes. We're going to compare the numerator degree to the denominator degree. What's the degree of the numerator? 0, because it's a constant. What's the degree of the denominator? 1. And isn't 0 less than 1? So what's the horizontal asymptote? Y equals 0. Always, when the numerator is less than the denominator. And so I want to label that as well. Y equals 0. So if you were to look at your calculator, it's going to plot, it's going to show a point at 1, 1. So if x is 1, y is 1. If x is 2, y is actually a half. What happens if x is a half? What's 1 divided by a half? What do you do with that half? Don't you flip it, because we don't divide by fractions, we multiply by the reciprocal. So it becomes 2. So this is a swoop that approaches those asymptotes and gets very close to them, but doesn't actually cross. So it does not intersect the x or the y-axis. I just chose values for x, so I started with 1. It's my favorite value, so I plugged it in. 1 divided by 1 is 1. And I plugged in 2. 1 divided by 2 is 1 half. When you plug in a fraction in the denominator, you have to multiply the numerator by the reciprocal of that denominator. So that's how when I plugged in 1 half, 1 times 2, which is a reciprocal of 1 half, that's how we got 2. Anytime the degree of the numerator is less than the degree of the denominator, you will always have a horizontal asymptote of x equals 0. Oh, this one? Except this, not equal to 0. Solved. It's already solved. So the only value that we give 0 in the denominator is 0. So x equals 0. Anything else is just 0. Okay? And so I'm going to do the same thing with -1, because I want some negatives over here. So if I plug -1 in, x is -1, the y value is -1. 1 over -1. when x is -2, 1 over -2 gives you a y value of -1/2. When x is -1/2, 1 divided by -1/2, multiplied by the reciprocal, -2, y becomes -2. So the second sweep approaches the same asymptotes because it cross. So this graph does not cross the x and y axis. They do not have x and y intercepts until we transform it and shift it. So then what's happening here is we're shifting the graph. So remember what happens when we do things to the x or do things to the outside of the function. The only difference between 1 over x and 1 over x plus 3, isn't it this plus 3 that's in there? Right? Isn't that occurring to the x? Isn't it occurring inside the function? There's the function, 1 over x. Isn't that occurring to the x? It is, but it's not on the outside. That's what the outside would look like. So when it's being added or subtracted to that x, it's occurring within the function. So the shift, if it's occurring with x goes right and left. So this is a shift. Inside the function, is it opposite sign or same sign? Opposite sign. So instead of plus 3, we're going to shift left 3 because we want to go minus 3. So think about on here what shifts. I have a horizontal asymptote, I have a vertical asymptote, and I have some points. Let's start with the asymptotes. Is a horizontal asymptote, can I move it left 3? I'm going to move it left 3. Does it look the same or different? Aren't lines infinite on both ends? You can move that left 3 all you want, but it's still going to be there, isn't it? So moving my horizontal asymptote left 3 does no good. What about my vertical asymptote? What happens when I move it left 3? Does it look different? Does not look different? So I can actually move the vertical asymptote left 3, but the horizontal asymptote stays the same. So that vertical gets shifted to the left 3. So you want to write it as a dashed line because it's not part of the graph, and you have to label it. Math Excel is not going to make you label it. I am. If you don't label it, you're going to lose points. So you get in the habit of doing it on your homework. Because the horizontal asymptote of y equals 0 did not change, I still have to label it. And then I can tell you without looking at my calculator that each of these points are going to shift the left 3 also. So I had a point that was here at 1, 1. It's going to shift to the left 3 also. 1, 2, 3. It's going to hug both of those asymptotes. So it's going to hug this asymptote and hug this asymptote, but not cross. This point that was here at -1, -1, it's going to move 3 to the left. It's also going to hug both of those asymptotes, but not cross them. So it's the same shape graph. All that happened was it got moved to the left 3. Only the x values were affected, not the y's. So there's no need for my calculator on that one. What about this one? What is the +4 on the outside doing for the transformation? Yeah, it's going to move it, it's going to shift it up 4 because it's occurring outside the function. When it occurs outside the function, it affects y. And so it's going to go in an up-down motion, and it's the same sign. So it's up 4. So what can move up 4? Can my vertical asymptote move up 4? That vertical asymptote doesn't move up 4. Doesn't really change where it is, right? But my horizontal asymptote, can't that move up 4? So that's the one that gets changed. So it's a dotted line. So that is y equals, because it's going to the y-axis, 4. My horizontal or my vertical asymptote did not change. That is still x equals 0. So go back to those ordered pairs, 1, 1, and -1, -1. I originally had an ordered pair at 1, 1. It's going to shift up 4 as well. it's going to hug those two asymptotes. That original point, -1, it shifts up 4 as well. And it's going to hug those asymptotes. Yes. Questions? Yeah. Oh. So is there questions on that set of? All right, so then example 2 is different because they're asking you to find the domain this time and describe the behaviors. You're going to need your calculator because although, well, A, you won't necessarily need your calculator because you can sketch that graph on your own. B, you're going to want your calculator. So the first thing I'm going to do is find my domain. What are my domain restrictions? To find my domain, if I were you, I'd be finding my vertical asymptote. What's my vertical asymptote? Not 1, but say it properly. It's x equals 1. Gotta write it as an equation. So if that's the case, then my domain is cut only at 1. So I go from -infinity. I hit that restricted value of 1. I don't want to include it, so I have a parentheses. Union that with, start with a 1 again, and go to positive. So there's your domain. Then if I were you, I would sketch the graph so I can see what my end behavior is doing. So I have a vertical asymptote at 1. So I'm going to dash that in and label it. Do I have a horizontal asymptote? What is the degree of my numerator? 0. The degree of my denominator? 1. 0 is less than 1. What does that mean my horizontal asymptote is? Y equals 0. If you think about it, this is the function we were just looking at. This -1 is affecting the x, and it's the opposite sign, so we should be shifting right 1. Isn't that what happened with my vertical asymptote? It should be right 1. And I'm going to have a swoop that goes in this direction, and a swoop that goes in this direction. So here's kind of the shift and the change in the limits. When we have vertical asymptotes, we are now going to approach the vertical asymptote with your limits. In other words, we're not going to approach infinity or -infinity unless there's not a vertical asymptote. If there's a vertical asymptote, we're going to write our limit notation like this. So the limit as x approaches. For every vertical asymptote, we will have 2 limits. A limit on the right-hand side of it and a limit on the left-hand side of it. This vertical asymptote is 1. So x is going to approach 1. I came up with 1 because that's the vertical asymptote. It's the restriction on the domain. So that's where my focus is. But I want to tell the reader that I'm approaching 1 from the right-hand side. So you have an elevated plus on the right hand showing that you're looking at the right hand of 1 on the graph. This graph is called f of x. So the limit as x approaches 1 from the right of the function is. So start from the right-hand side of 1 and start approaching it. You're sitting on that graph like it's a roller coaster and you're following its direction. So as I approach 1 from the right-hand side, I'm on this right-hand swoop, true? What's that swoop doing as I get closer and closer to 1? It's approaching positive infinity. So that's the limit. That's the right-hand limit at 1. Now let's approach 1 from the left. So we've got the limit as x approaches 1, but from the left-hand side. And this is still f of x. So this time I'm approaching the graph, but from the left side. Aren't I on the lower swoop this time? From the left? Because that's the part of the graph that's to the left of that asymptote. So as I approach and get closer and closer to 1 on the left side, what's the graph doing? It's going down to negative infinity. What I want to introduce you to the fact is that there is the limit to the graph does not exist, and here's why. The right-hand and left-hand behaviors at 1 do not agree. For the overall limit to exist at 1, the left and right-hand behaviors have to agree. So although there's a right-hand behavior and a left-hand behavior, the overall limit does not exist. Remember the whole Mean Girls thing? There's a little clip in Mean Girls where she's on the mathletes or whatever, and she's in a competition, right? Well, this is what she's viewing. This is how she's answering that question. So she's determining if the limit does not exist. And so because as I approach from the left and the right, I'm going in opposite directions, and they don't agree with each other, the overall limit does not exist. They're not going to ask you that yet in Math Excel. I'm just introducing you to that thought. Look at part B. So part B, let's find a vertical asymptotes, because that's going to help me find my domain. So I want to take x squared minus 1, and I want to set it not equal to 0. Can I factor that? Yep. X plus 1, x minus 1 cannot equal 0. If I set those equal to 0, I get x cannot equal to 1, and x cannot equal 1. Those are my vertical asymptotes. What about my horizontal asymptote? Why? Hold on, my dad's not ICU. My dad, 007, he goes to death every day. I can only approach it with him, but he almost died yesterday, so I did not grade the process because I was at the hospital all. So yes, I answered myself. Because when I didn't answer it yesterday, he wasn't doing it, so I answered it today. So yes, you're correct, because the degree of the numerator is less than the degree of the denominator. You have a horizontal asymptote that's y equals 0. So I have a horizontal and a vertical. So when I go to sketch this, you're going to want your calculator. I have my vertical is at -1. Label that. And at +1. And you want to label that. And then I also want to label my horizontal asymptote here at y equals 0. So you should see your graph approaching all three of those asymptotes in some fashion or another. So I'm going to put it in 1 divided by, use parentheses, x squared minus 1. So it looks interesting. You have 3 parts to the graph. So you've got a swoop on the left that's approaching this horizontal asymptote and this vertical asymptote. So it approaches both of those. And then you have a swoop on the right that approaches both of those in that first quadrant. And then this is like a parabola. And if you want to know where it crosses the y-axis, just let x be 0. If x is 0, you get 1 over -1. So it crosses the y-axis at -1. And it approaches both of these. So it looks like a parabola opening down. So our limits are interesting. Because I have 2 vertical asymptotes, I have 2 limits per vertical asymptote. So how many limits am I going to have altogether? 4 limits altogether. So let's start with the leftmost vertical asymptote. So how do I know what x is approaching? I look at my vertical asymptote. So this vertical asymptote is -1. So the limit as x approaches -1 but I want to approach negative 1 from the right-hand side. So you should have an elevated plus there. They are calling this function f of x, so it's of f of x. So I'm going to approach the graph from the right, and I'm going to get close to negative 1. You need to figure out what part of the graph you would be standing on, or riding on if it's your roller coaster. So as I'm to the right of negative 1, am I at this swoop or the parabola? I'm at the parabola because the parabola is the part that's on the right-hand side of negative 1. Agree? So if I'm sitting on this parabola and I get closer and closer to negative 1, what's the direction of the parabola going? To negative infinity. So the limit as x approaches negative 1 from the right is negative infinity. Now I want to approach that same number but from the left. So the limit as x approaches negative 1, but this time from the other side, from the left side of the function. So now I'm approaching negative 1 from the left. Am I on the swoop or the parabola? The swoop is on the left-hand side of that negative 1. So then follow that swoop as you get closer to negative 1. What's the direction of the graph going? To positive infinity. Does the left and right-hand behavior agree? No. Is there an overall limit? No. Is there an overall limit at negative 1? No. The limit does not exist at negative 1 because you're going in opposite directions. All right, so we have another set of limits at positive 1 because that's the other vertical asymptote. So we're going to look at the limit as x approaches positive 1 this time. But I want to approach it from the right-hand side, so I'm putting an elevated plus, and it's still f of x. So as I approach positive 1, am I on the right swoop or the parabola? The right swoop. Is that swoop going up or down as I get closer? It's going to positive infinity. So then look at the left-hand behavior. The limit as x approaches positive 1 from the left. It's still f of x. So this time I'm coming from the left, getting close to that 1 from the left-hand side. Am I on the right-hand swoop or the parabola? The parabola. And what is the direction of the parabola doing? It's going to negative infinity. So does the overall limit exist at 1? No, because the left and right hand does not agree. Look at example 3. I want you to write the limit on your own. You have to figure out what is x approaching. Approach it from the right and the left side, and then what is the limit? So what value will x be approaching? Will x be approaching 0 or will x be approaching 3? And that's the question you have to ask yourself. How do you know? What will we be approaching here on all of these green numbers here? Where did I get all these green numbers? They're vertical asymptotes. So what's the vertical asymptote here? 3. So it's x equals 3. That tells you what x is approaching. So you want to approach 3 from the right and from the left and determine what that limit is. So you write the limit equation. When you get your answer, I want you to share it with those around you, see if they agree with you.
0.
Uh-huh.
So is it because you looked at the right side of the
Of negative 1. That's the right side of the vertical asymptote of negative 1. So for instance, on this one, so here's your vertical asymptote of negative 1. As I approach it from the right, there I'm approaching from the right, I'd be on this part of the graph, that graph.
Yeah.
As I get closer and closer to the right side of negative 1, it's in the graph and going further and further. And so that's why that limit is on.
So it's on the left side, so now it's just 5
We mean it's still on the left side.
Oh, do you approach it from
I
which
approach
axis
it
do you
from,
approach it from?
I approach it from both left and right. And I'm approaching it based upon the direction of the x-axis, but I'm looking at what is wider. So as I approach it from the left side, not this direction, I'd be on this surface this time, because that's the part that's to the left of negative 1. So as I get closer and closer, the negative 1 on the left side, isn't the graph going up? Positive. So that's why that one is positive. So you're just looking at what part of the graph is to the left or right of that vertical asymptote, and where is the graph going? Is it going to the positive infinity, negative infinity, or is it approaching it infinity? Okay. All right, so let's look at your limits. Yes. Because you have 2 limits for every vertical asymptote. Because when I approach this vertical asymptote, I have to approach it from the right side and the left side. When I approach this vertical asymptote, I have to approach it from the right side and the left side. So for every vertical asymptote that you have, you will have a right hand and a left hand approach to it. So this one only had 1 vertical asymptote, so I only have 2 limits. I approach it from the left and from the right. So as I approach 3, that's my vertical asymptote from the right, as I approach it from the right, I'm on this swoop down here. So as I approach it from the right, and I'm getting closer and closer to 3, that graph is going towards negative infinity, isn't it? And it's without bound. So that's why my limit is negative infinity, because the closer I get to 3 on the right-hand side, the more negative that number is going to get. But if I switch it and approach 3 from the left-hand side, this one, I'm now on this left swoop over here, because that's the part of the graph that's to the left of that asymptote. So as I get closer and closer and closer to 3 from the left side, won't the y value get bigger and bigger and bigger and bigger without bound? And so it's approaching positive infinity. So I have to do that for every vertical asymptote. Questions? The more of these you do, the better you'll get at them. And if you don't understand why the answer is what it is, you've got to ask the questions, because at one point it's just going to click. You go, oh, I get it. And there's some different ones. So let's look at this back page. And there's a few on here that are different. So this one, you're finding the vertical asymptotes, horizontal asymptotes, and you're describing the behaviors. So vertical asymptote means that we are going to set the denominator equal to 0. So I'm going to take this denominator, vertical asymptote, x squared plus 1 cannot equal 0. Can x squared plus 1 be factored? Nope, I can't factor this on the 2 squared. But, I mean, I could subtract 1, and I take the square root of both sides. Wouldn't I get an imaginary number? So what that tells you is it's impossible for the denominator to be equal to 0. It's impossible for x squared to have a value of negative 1, isn't it? Because it's squared. It'll always be a positive value. So there is none. None. So if there's no vertical asymptotes, how do we know where x approaches on our limits? Well, we'll talk about that. Let's look at our horizontal asymptotes. Horizontal asymptotes, we want to compare the degree of the numerator to the degree of the denominator. So what's the degree of the numerator? 2. What's the degree of the denominator? 2. Aren't they equal? So when they're equal, you want to compare the coefficients of the leading terms, leading coefficients of the highest degree terms. And the x squared term has a leading coefficient of 1. So we end up with y equals 3 over 1, which is y equals 3. So that asymptote I'm going to put in as a dashed line. Then you're going to take your handy dandy calculator and you're going to plug this in. So I've got 3x squared divided by x squared plus 1. Doesn't look like a burden flight. And it does cross the x and the y axis. If I want to know where it crosses the y axis, I let x equal 0. If I let x equal 0, the numerator has a value of 0. The denominator has a value of 1. 0 divided by 1 is 0. So it crosses the y-axis at 0. And the right-hand side is increasing, but it's approaching this asymptote, right? The left side technically is decreasing. The rows go from left to right, but it's approaching that asymptote as well. So how do you write the left and right-hand behavioral limits? If you don't have a vertical asymptote, then your limits as x approaches, and then this is an f of x. Don't have a vertical asymptote, you are going to approach positive infinity and negative infinity just like we did before. And you're going to evaluate what the graph is doing. So as I go and I approach positive infinity, so that means I'm going to the right on the graph. What is happening to y? It's increasing. Does it increase without bound? Isn't it bounded by the horizontal asymptote? So y is getting bigger and bigger and bigger and approaching what number? 3. It never actually crosses and gets bigger than 3, and it never becomes 3, but it is approaching the number 3. And so that means as x approaches positive infinity, y, the limit, is approaching 3. Yes, it's increasing, but it has a bound, has a limit. Now we're going to approach negative infinity, so we're going to go to the left. Look what happens as we go to the left. Isn't y increasing again? If we go to the left, is it increasing without bound? Because if it increases without bound, it would be positive infinity. But it doesn't. It's bounded by what number? 3. So it agrees with the right-hand limit. If the left-hand limit and the right-hand limit agree, is there an overall limit to the graph at x equals? Is there an overall limit to the graph here? Yes. The limit is 3. And think about it this way. The graph is bounded above, and isn't it bounded at 3? So it makes sense that it has a limit of 3. Y value cannot go past 3. So that one's different. Then look at B. Let's find a vertical asymptote. So we're going to take our denominator, x squared plus 2x minus 3, and set it not equal to 0. Can I factor that? Yes, I can. So x squared becomes x and x. What factors of 3 subtract to give you 2? 3 and 1. I want my 2 to be positive. So the bigger of the 2 is 3. That means 3 is positive. What would the 1 have to be to make a positive term? It would have to be negative. So it said either those equal to 0, x cannot equal negative 3, and x cannot equal 1. So you have 2 vertical asymptotes. How many limits are you going to have? 4. 2 for each one. We're going to end up with 4 limits total. So we're going to put in our vertical asymptote of x equals negative 3. So dash that line. And 1 at positive 1. We still have to find the horizontal asymptote. So we have to compare the degree of the numerator to the degree of the denominator. What's the numerator's degree? 1. What's the denominator's degree? true. Isn't 1 less than 2? What's the horizontal asymptote when the numerator is less than the denominator? Y equals 0. So we're going to label this as y equals 0. So now when you plug it into your calculator, you should see the graph approaching all 3 of those. So parentheses x plus 2 divided by parentheses x squared plus 2x minus 3. So if you want to find exactly where it's crossing the y-axis, that you can find the 0 by using top 0, I will tell you that experience shows that if I have 4 units distance between this asymptote and this asymptote, half of that is 2 units. So if I go 1, 2, isn't that right in the middle? Isn't -1 right in the middle of those 2 numbers? True or false? Okay. Then my S-curve is going to hit the graph right there and approach the other 2 asymptotes. And then I have my right swoop is up here approaching these 2 asymptotes, and my left swoop is down here approaching those 2 asymptotes. Yes? Let me see your calculator. You have to put the numerator x plus 2 in the box.
Oh,
Because otherwise you're just taking 2 and dividing it by 4. Are we all good and okay? Okay. So then let's go ahead and look at our limits. So I'm going to have 4 limits. So let's start with our leftmost vertical asymptote. Isn't it at -3? So I'm going to approach -3 from both the right and the left-hand side. So put an elevated plus. We're calling the function f of x. So let's look. As I approach -3 right here from the right-hand side, am I on the right swoop, the left swoop, or the middle S? Which is most directed to the right? Isn't the S correct? So as I approach and get closer to -3 on the right-hand side, what is the graph doing? It's going up without bound, isn't it? Isn't that positive infinity? So then we're going to approach -3 from the left side. And that's f of x. So as I approach -3 from the left, am I on the right swoop, the S, or the left swoop? I'm on the left swoop. So as I get closer and closer to -3 on the left side, isn't the graph going down? Is it without bounds? It's without bounds, so it's going to negative infinity. So that takes care of the vertical asymptote at -3. Now we have to look at the vertical asymptote at +1. We're going to approach that from both sides. So the limit as x approaches. The limit as x approaches. So I'm approaching +1. I'm going to approach it from the right and from the left. And both of these are f of x. So as I approach 1 from the right, aren't I on the right swoop? As I get closer and closer to 1 on the right-hand side, what is the right swoop doing? Going up to +1. What happens as I approach 1 from the left? I'm on that S curve, and isn't it going down to -1 the closer I get to the left side of 1? And so this limit is -1. Does the limit exist at -3? Overall limit exists at -3. Does your left and right hand agree? Nope. So the overall limit does not exist at -3. What about at 1? Does the overall limit exist at 1? Nope, because the left and right hand don't agree. Questions on that before we do slant asymptote? Okay. Yes.
So you guys want to go from right to left?
You're going to the right side, and then and to the left side. So you're going in opposite directions towards that vertical asymptote. So from one I'm going right left, and the other one I'm going left right. So this one they're asking to find the slant asymptote. Well, first of all, let's find a vertical asymptote. Your vertical asymptote, don't I just set this not equal to 0? So isn't x not equal to -3? So I'm going to put that vertical asymptote in. Dash line. X equals -3. Then if you look at the degree of your numerator, which is 2, the degree of your denominator, which is 1, the numerator is greater than the denominator, so there is no horizontal asymptote. So instead, there's a possibility of a slant asymptote because this is exactly one difference, and it's a 2 to a 1. So we're going to use synthetic division. Or am I missing anything in the numerator? In terms? No. So I've got 1, -3, and -7. So draw your upside down L, your shell from your vertical line. I am dividing by x plus 3, so what goes on the shell? And -3. Bring down the first number and start your multiplication process. -3 times 1 is -3. Add down is -6. -3 times -6 is positive 18. Add down is 11. I don't care about the remainder. All I care is about that. And so that should be in y equals mx plus b form. So this is y equals, it was x squared, and now this is an x. So my slant asymptote is y equals x minus 6. So this time it's a little bit more complicated. So I'm going to actually graph that properly. Doesn't it cross the y-axis at -6? So plot a point on the y-axis, and it has a positive slope of 1. So up 1 to the right 1, up 1 to the right, and keep going until you fill up the whole grid. I'm going to dot that line. And that is y equals x minus 6. So then I'm going to throw this into my calculator. And I get parentheses x squared minus 3x minus 7 divided by x plus 3. So it's kind of a weird one. It intersects the y-axis. It appears to be somewhere around -2. So I'm going to keep that in mind, somewhere around there. And it crosses the x-axis somewhere around, it looks like about somewhere around -2, 2, 3, 4, and maybe at 5. If I wanted the exact numbers, wouldn't I do second calc? Or wouldn't I factor this, right? That kind of thing. Well, we're just sketching here. So I'm going to swoop it through here. And so it's approaching this slant asymptote on the right and this on the left. Just as an aside, the left hand, if I were to do a limit, the left hand limit as x approaches -3 from the left, is there any graph over here? It does not exist. Just as an aside. All right, so there's possibly one question, maybe two, that you won't necessarily know how to do on your homework, so bring questions tomorrow.